Hello and welcome to Know It Training's course on virtualization and the cloud. This course was designed to give you a better understanding of the breakthrough technology of virtualization and how virtualization has made cloud computing possible. During this course, you'll learn what virtualization is and how it works. You'll see how virtualization is used to make a single device serve the purpose of many devices, and learn how this has led to the IT revolution of cloud computing. The word virtual means being very close to something without actually being it. This might be a little confusing until you think about the example of virtual reality. If you sat down in a crowded coffee shop and put on a pair of virtual reality goggles, you might get the impression that you're standing alone in a meadow surrounded by tall trees and mountain peaks in the distance. In reality, you're wearing a pair of VR goggles in a room full of people who are probably staring at you. However, the software running those goggles is creating a three-dimensional image of a meadow, trees, and mountains. If this image is realistic enough, your eyes are fooled into thinking that the meadow, the trees, and the mountains are real. Well, the virtualization of things in the IT world works in much the same way. While virtualization is a hot topic in computing today, the concept has actually been around for quite a while. Let's take a look at some classic examples of virtualization, virtual memory, and virtual operating systems before we fly into the cloud. In the early days of computing, memory was really expensive. Computers didn't have nearly as much memory as they do today. If the size of a program was 2 megabytes and the available random access memory, or RAM, was 1 megabyte, then the size of the program was greater than the amount of available RAM, and the program simply could not run. So what the designers did was to fool the computer system into thinking there was more memory than there actually was. This new memory was called virtual memory, created by setting aside some space on the hard drive and telling the operating system, hey, don't worry, we have enough RAM to load your program. For example, if RAM memory was 1 megabyte and the program size was 2 megabytes, the system would use 1 megabyte of hard drive space to store the program overflow. It's important to note that programs running virtual memory take more time than programs running completely in RAM. This is due to the fact that hard disks are significantly slower than RAM. Still, users are happy to live with the slower speeds because it allows their program to run where without virtual memory, it could not. Another classic example of virtualization is the ability to have your PC act like a Mac and vice versa, with programs such as VirtualBox or VMware. This software is widely used by PC users who want to run Mac-only programs on their PC, or Mac users who want to run PC programs on their Macs. Programs like VirtualBox or VMware are actually creating a virtual computer within a computer. This virtual computer is often referred to as a virtual machine. A virtual machine is software. It runs as a program in a window on the current operating system. If you are on a PC and you want to run as a Mac, you simply switch to a window and interact with the computer as though it were running the Mac operating system. Many users take advantage of virtual machines to experiment with different operating systems without having to commit to a large-scale installation on their computer. When done with the experimenting, they can simply close the window and delete the virtual machine. The beauty of these virtual machines is that they are sandboxed from the rest of your system, which means software running inside a virtual machine can't escape out and interfere with the rest of your system. As we'll see, this sandbox feature of virtual machines makes it very attractive to use in cloud computing, where entire servers are virtualized. In the old IT world, servers were just boxes made up of lots of hardware components. Opening a server box, you would see a microprocessor, or CPU, memory cards, or RAM, and a hard drive. The server operating system, entirely made up of software, was specifically designed to run on that hardware. And you could only have one server operating system running on one set of hardware. For this reason, the hardware and the operating system were not thought of as two separate things. They were thought of as two parts of a single server. However, as IT changed, this created some serious problems. Let's take a closer look. Despite its enormous processing power, the server's hardware was limited to the work required by its single operating system. As a result, the capacity of the hardware was woefully underutilized. Sometimes as little as 5 to 10% of the hardware's capacity was in use at any given time. As the types of services that servers provide grew, IT departments had to deploy new servers in their networks for each service, since each server had to have a place to sit and power to operate. The result was a big waste of space and energy, both of which come at a cost. Since server operating systems were designed to run on a specific set of hardware, if you wanted to put a new operating system on a set of hardware, it wouldn't work. You had to buy hardware to match the new operating system and toss out the old hardware, or modify the operating system to run on the existing hardware. Both options can be very expensive and time-consuming. The answer to all three problems lies in virtualization. Server virtualization takes the concept of the virtual machine to the next level. Let's start with a basic server that has a set of hardware and a server operating system designed to run on that hardware, just like in the previous example. But now let's add a virtual machine, which is easy because it's software. With our virtual machine, we can now run different server operating systems just as if they were running on their own hardware. And since you can have several virtual machines running on a single server, you can now run lots of server operating systems on one set of hardware. Here's how it works. The virtual machines, much like your virtual reality goggles, create the appearance of something that isn't there. But instead of trees and mountains, the virtual machine creates the appearance of different hardware. When you load a new operating system on the virtual machine, the OS is fooled into thinking it is running on the hardware it was designed for. The virtual machine fools the operating system by sending and receiving signals, just like the right hardware would. The virtual machine fools the new operating system in another important way. It makes the new operating system think it's the only OS running, just as your virtual reality goggles make you think you were alone in a meadow, even though you were in a crowded coffee shop. The VR goggles do this by showing your eyes only what they want them to see. Server operating systems don't have eyes. Their only interaction with the world around them is through signals they send and receive. Since the new operating system is receiving its signals from the virtual machine can show it only what it wants the new operating system to see. The result is a single set of hardware, which we now call the physical server, with multiple operating systems running on top of one or more virtual machines. And those operating systems are entirely separated from one another, thanks to the power of virtualization and the sandbox concept. This virtualization technology has literally changed the way we think about servers in the IT world. We no longer think of the physical server and the server OS as two parts of one thing. We now think of the physical server as just a platform, and each of the server OSs running on it as separate virtual servers. Looking at servers in this way has led to another big benefit: flexibility. Because the virtualized servers and the virtual machines they run on are no longer tied to the physical server's hardware, they can move. For example, a company might have 4 physical servers in their network. Each of these physical servers might have 4 virtual servers. If one of the virtual servers starts to use too much of the physical server's processing power, the other virtual servers can be moved off that physical server and redistributed among the other physical servers. Server virtualization is a huge step forward. It created an IT environment where the physical server's hardware could be more fully utilized, so additional hardware purchases weren't necessary. It also drastically reduced the space and energy required for physical servers. It also created huge possibilities. Advances in IT are driven by creative, intelligent people asking the question, what if? And somewhere along the way, someone asked the question, Since we can make a virtual machine act like a server hardware, what if we made it act like other kinds of hardware? For instance, what if we could make a virtual machine act like the hardware inside a switch or firewall? Could we create a virtual firewall or virtual switch? The answer is yes. Over the past several years, a cooperative effort between 3 industry giants has created another breakthrough in virtual IT infrastructure. VMware is an industry leader in virtualization technology. Cisco is the heavyweight champion of routing and switching, and EMC is a leader in data storage. These 3 companies formed a joint venture called VCE, which has produced the equivalent of a full-blown data center in a single rack, with all of the necessary infrastructure components. Routers, firewalls, switches, even your company's phone system, all virtualized on servers. What would usually have taken up one entire floor of an office building in the old world of IT is now no bigger than the average file cabinet. Overall, virtualization has greatly changed the way companies manage their computing resources and has opened the doors to new business models. For example, Amazon, which began as an online bookseller, is now making millions by supplying computing services based on virtualization technologies. Companies that rely on computers and databases to run their businesses no longer have to buy servers and databases and house them in a special air-conditioned facility. Instead, they can lease servers and databases in the Amazon cloud, a term that simply means multiple servers available using the internet. Let's take a look at the concept of cloud in a little more detail. Cloud computing simply means out there on the internet. In our discussion of virtualization, we saw that a company can outsource its server needs to a provider such as Amazon. But that's not the only way to take advantage of cloud-based virtualization. In the industry, we talk about 3 flavors of cloud computing, or service models. These 3 basic service models are IaaS, Infrastructure as a Service, PaaS, Platform as a Service, and SaaS, Software as a Service. Let's take a look at what these AaaS services look like. Infrastructure as a Service, or IaaS, helps companies with basic infrastructure needs by making pieces of what they need available in the cloud. For example, a company may need a server that runs the Linux operating system. Companies such as Amazon Web Service and Rackspace can provide you a server running Linux in the cloud. With IaaS, a company is basically renting a virtual machine, or VM for short. From the provider's perspective, it's basically, here's a virtual machine in the cloud running the version of Linux you requested. Go for it. For companies taking advantage of IaaS, the details of what to do with the VM server in the cloud is up to the company, such as loading programs and data to run on the server. It's much like renting space in a storage unit facility. You get a giant empty storage unit, and what you put in it is up to you. With IaaS, the main advantage for a company is that they do not have to buy a server and worry about its maintenance. That's all handled by the IaaS provider. However, loading software on the virtual server is up to the customer. PaaS, or Platform as a Service, is one level up from IaaS, where cloud providers not only take care of the components that IaaS does, but also manage the platform-level software. For example, a company could specify, I need to run a .NET server and use a MySQL database, or I need to use a Tomcat server and run Java. With PaaS, all the needed software will be pre-installed on the virtual machine. As a customer, you simply need to focus on managing the applications and data, not on uploading them to the server. Of course, PaaS is more costly than IaaS. PaaS market players such as Google App Engine, Windows Azure Platform, and Salesforce.com will handle all the software deployment details for you. Software as a Service, or SaaS, is probably the most common cloud service, one that you may already be using without realizing it. With SaaS, all one needs to do is use the service. Everything else is taken care of for you. The classic example of SaaS is Google Gmail. Think about it. You just use it without ever worrying about where across the vast expanse of the internet your email is actually located. Other examples include Microsoft's Office 365 and Google Docs. Where is the server? Who cares? It's in the cloud. You just use it. That's what software as a service is all about. There are numerous advantages in using the cloud for IaaS, PaaS, and SaaS. They include unlimited storage capacity. Cloud computing offers virtually limitless storage. Your computer's current 1 terabyte hard drive is tiny compared to the hundreds of petabytes available in the cloud. Increased data reliability. Unlike desktop computing, where a hard disk crash can destroy all your valuable data, a computer crashing in the cloud will not affect your data. No matter what, your data is always in the cloud, accessible whenever you need it. And in a world where few individual computer users back up their data on a regular basis, cloud computing is a data-safe computing platform. Universal document access. Documents are instantly available from wherever you are. They stay in the cloud, and you can access them anywhere you have a computer and an internet connection. Pay only for what you use. When you use cloud services, your monthly payment is based on usage. Virtualization technology and its realization in the different forms of cloud computing have totally revolutionized how companies think about IT services. Have a startup idea? With very little upfront investment, you can set up a server and a database in the cloud and test out your ideas. If your idea is a success, with the press of a button, you can increase the number of servers and handle all the millions of visitors to your website without having to hire IT support staff or even leave your desk. This concludes our course on virtualization and the cloud. You've learned what virtualization is and how it works. You've seen how virtualization is used to make a single device serve the purpose of many devices. And you've discovered how this has led to the IT revolution of cloud computing. I hope you've enjoyed this course. In our next course, IT Security, we'll learn about the many IT security threats that exist and the technologies that have evolved to address them. See you next time!